Hello everyone. Hope all of you are doing very well at home because the situation is very critical now and it is better to stay home to save ourselves and to save others. So and nowadays we have technology and we can work from home, we can learn from home. So it is better to stay at home at the situation and to do something productive. So today Dreamscape Design and Constructions is going to announce something really different. We have decided something to give away. But before this announcement, I'm going to explain the total design process of a structure, how the approach should be to design a structure, and after this webinar, you can say a little description about the structural design. I'm going to announce the today's topic. So let's start. So while coming to design of a structure, the first and foremost thing that we need is a architectural drawing. Okay. So the first thing we need is the architectural drawing. Now you can say why it is a architectural drawing, because we are talking about structural design, right? So why here architectural drawing and all? Because see, why architectural drawing is consist of the plans of different floors, okay, plans, and we have elevations. Okay, we have sections of the structure of the building or the okay. So now why we need all these things? Because from the plan we can get the position of the walls, the position of different rooms, okay, the position of kitchen, the position of bathroom, whether it is a bedroom or whether it's a lobby or balcony, where the staircase should be, or the placement of the staircase. Okay, so considering all these aspects, we are going to create the structural plan. Okay, the structural plan means the positioning of the beam and columns. Now why elevation? From the elevation we can understand uh, the floor heights and where the floor position is. Some floors, maybe the balcony is a bit down from the floor height, so we can understand the position from the elevation, but from the plan view it may not clear to us. Okay, so that's why plans, elevations and sections means maybe a typical staircase. Okay, now how the staircase is going from which side to which side, so from a section we can get the proper idea of the staircase. Okay, or maybe a room. So architectural drawing is very important at the beginning of the structural design. So after getting the architectural design drawing, we need to make decision about the position of beams and columns. Okay, the position of beams and columns, where we should place the columns and how many numbers of columns we should use. Always we should consider minimum number of columns, and still the structure should take the load, structure should stand. So we should consider minimum number of columns and where we should place those columns, where the beam should be, and which is the appropriate place to keep the beam. So this is the first decision we should make before going for structural design. And then the thing is column orientation. Okay, column orientation. So what is column orientation? Let us consider this is a beam plan. Okay, these are the beams. Here, these 4 points we should place 4 columns. Okay, so maybe this direction is, this length is A and this length is B. Okay, and consider B is greater than A. Now, and we have a rectangular column like that. This is A, this is B. Now, how the placement of the column should be, whether this should be like that or this should be like that. So we need to understand this topic, that how the column orientation should be, and it may depend on the effective span we have, the clear span we have. It may depend on the rooms corresponding to that column position. Maybe it is a bedroom or kitchen, if it is taking more area or not. So considering all these aspects, we need to create the beam column plan. No, actually we should not draw it. It's just a decision. So after making a rough decision of the beam and column position and the orientation of the column, then the most important thing we should do is the creation of mathematical model. Okay, creation of mathematical model. Now, what is mathematical model actually? Let me show you. So let us say we have various softwares, right, for architectural planning and design. For arc planning and design, we have AutoCAD, we have Revit, we have Rhino, then and various other softwares, right? And various other softwares we have to create the architectural plans and drawings. So after creation of architectural planning, we need to go for structural design, right? Structure design. So for that, we have different software. The most popular softwares are ETABS. We have SAP 2000. Then we have StatPro. Then we have Midas Gen. Okay, Midas Gen we have, and so many softwares are there. A bunch of softwares are available in the market. So among any of these softwares, you need to create the mathematical model. So what is the mathematical model? The model, or the structure. You can say it's a miniature model of the structure, which will give us the real-time values. Okay, if the structure is constructed in the field, and what are the forces will be coming on the structure, and what will be the movements, what will be the reaction values. All these values we should get for the analysis and design of the structure, right? So to get all these values, we need to create a structure in one of these softwares. So let me show you one thing. In ETABS, I have created a structure which is a G+4 structure, and this is with overhead water tank and a lift room. Okay, lift machine room, and this is an industrial structure. So with a core wall, which is the lift shear. Okay, lift core wall. You can say the lift shaft. So now we can get the values of forces, movements, and the reaction values, all these kind of stuffs from this structure. So this is called the mathematical model. Now, after creation of mathematical model, what we need to do? We need to go for loading process. So this is the next part. So what are the loading process? So let me tell you one more thing. While a creation of the mathematical model, there are so many things we need to consider. That is the material properties, So what are the materials? Maybe concrete, maybe steel, there will be rebar, there will be precast sections. Okay, so precast, it may be in concrete also. So concrete, what are the concrete grades? Maybe M20, 25, 30, and etc. What is the steel grade? Maybe. And what is the rebar grade? Maybe Fe 415, 500, and steel grade. Maybe there are so many steel grades you can see. So So these things we need to consider, and after that we need to consider the section properties, material properties, then section properties. Now what are the section properties? The size of the initial size of columns and beams and slabs. Okay, maybe the walls. So after creation of the mathematical model, we will go for the loading process. Now what are the kind of loads we have? We have different kind of loads. The basic loadings are dead load, we have live load, and we have lateral loads. Okay, we have lateral loads. Now what are the dead loads, live loads, lateral loads? So in lateral loads we have again seismic load, and we have wind load, right? We have wind load. So now you can ask how we can calculate all these values, where we can get the values of dead load and live load. Okay, so now in that case we need to consider the code books. We need to consider the code books. So every country has their own code book. As we are in India, so we have the Indian standard code books, which are IS codes. So we need to have the proper knowledge about our code books. So now for dead load and live load we have Indian standard 875 part 1 and 2. So IS 875 part and 2 for the values of dead load and live load. You can get the values of dead load and live load for IS 875. So now this is not same, like for all the structures the dead load and live load values will not be same. There are types of structures like residential structure, okay, like residential building we have, maybe it is an industrial building, okay, maybe it is a commercial structure. So we need to consider the type of structure, and according to that we need to get the values from these code books, okay, for dead load and live load. So after dead load and live load, these are the initial loads or basic loads you can say, then we will be considering the lateral loads. Now what are the lateral loads? And there are so many loads, maybe it is a temperature load, maybe and so many things. So the basic load cases we have the lateral loads. So for seismic load we have IS 1893, maybe it is 2002 or 16. Then we have for wind load we have IS 875 part 3 for wind load calculation. Now in wind load also we need to consider the types of structures, type of structure, then the area. Same for seismic load also and wind load also. Type of structure will be, we need to consider the area or the site, area or site, okay. Then we have, okay, let me go to another page, and so let me consider the seismic load now. Seismic load. Now, so we'll be getting the values for seismic load from IS 1893, right? So for seismic load we need to consider various values like time period. So for time period means the basic time period for the seismic load, okay, the base shear. So the time period from where we can get, same from the code, okay. So for different kind of structures like SMRF, special moment resisting frames, for OMRF, okay, for maybe it is a bare structure, maybe it is a structure with infill walls, okay, maybe it is a composite structure, okay. So depending on the type of the structure we'll be getting the formulas for the time period from IS 1893, maybe part 2, IS 1893 part 1 actually, part 1, okay. So then we'll be getting the response reduction factor, which we denote as R. Now for R also we have depending on the type of structure we have different values for R. We need to consider that. Then we have importance factor, which we denote as I. This is also depending on the type of structure. Now importance factor means the occupancy and like how the structure is going to be used. Maybe it is an industrial structure, then the importance factor will be different. Maybe it is a commercial structure, its importance factor will be different. Maybe it is a residential structure, then its importance factor will be different. So depending on the occupancy or its use, then we'll be getting the importance factor I value. And then we have the base shear calculation and all this kind of stuff. And for wind load, we need to consider, okay, here we will be getting the site condition also. Okay, the soil site condition means the soil type. Okay, the soil type. What is the type of the soil on which the structure is going to be built, right? So the type of the soil also give a response due to which we'll be getting the base shear. So after that we have the another lateral load, which is wind load. Now here we need to consider the basic wind speed of the area. Okay, basic wind speed. Then we'll be having K1, risk coefficient value. Then terrain category. Okay, terrain category. What is the category of your terrain where the structure is going to be built? Then we have the structure class. Structure class means the depending on the width and breadth and the height of the structure, we need to consider the structure class. All these things are we'll be getting from IS 875 part 3, right? IS 875 part 3. Then we have K3 values. Okay, then we have CP value, which is wind coefficient, right? Wind coefficient. CP value, that also will be getting from IS 875 part 3. Depending on the orientation of the structure, we'll be getting for windward direction and for leeward direction. Now what is windward and leeward direction? You need to understand, you need to catch those topics. In my online course, I have explained all these topics step by step. What is CP and how to calculate the CP from the IS 875 part 3. What is the K1 value, K2 value, and how you can get the values from the code book. And so these are all about the lateral loads. So after completion of assigning the lateral loads, let me show you in the software. I have assigned all these loads here. You can see the dead load, the live loads. We have the lateral loads here, and you can see I have said the zone factor, importance factor, soil type. We have the response reduction factor, time periods. Then for wind load, we have the basic wind speed, terrain category, structure class, K1, K3 values, CP values for windward and leeward. Okay, all these things we need to consider. So it's not like we'll be considering by our own. All these things are mentioned in the code. We need to read the code, we need to get the point, and we need to grab the value from there. Okay, right? So the most important thing while designing a structure is the code, the corresponding code of your country or of your area. So we need to refer those codes, we need to read these codes, which is very important. So the reading the whole code is very tedious, right? So we need to understand which parts we should we should read, and we should get those values from there. So in our online course, it is very clearly explained where we should get the values, or where we should use those codes in specifically. Okay, so after completion of the assignment of these loads, dead load, live load, and seismic and wind load, we'll be going for the analysis. Now we have different kinds of analysis. We can divide the analysis. You can let me write here. We can divide the analysis basically in two types. One is static, other one is dynamic. Okay. So in static and dynamic, both we have linear and non-linear. Okay, for both. In dynamic also we have two, linear, non-linear. Now what is linear and non-linear? Actually, while doing the static analysis, the software or in manual calculation also will be considering considering the linear property of the material, or maybe the non-linear property of the material. And same in case of dynamic analysis also, we may use the linear property of the material, the linear condition, or maybe the non-linearity of the material. Okay, so considering the linearity or non-linearity of the material, we will be doing the static analysis or else dynamic analysis. Now when we should go for static analysis, when we should not go for static analysis, we need to understand, and which is written in the IS codes, okay, or maybe your corresponding code. So in static analysis, we used to do the equilibrium static method, EQSM, okay, and in dynamic analysis we have response spectrum analysis, and we have time history analysis. Okay, time history analysis. And another type of analysis we have, which is modal analysis. So you can considering all these analysis results in a structure is very tedious if you are doing manually. But in case of our softwares used to give these values or do this analysis in just one click, and it will take hardly 10 seconds to complete the whole process. So let me show you one. I'll be clicking on the analysis, and will show that the analysis is completing in just few seconds. So you can see the progress bar, it will be showing that the analysis is completing. You can see how fast the process is going for every single mode case or every single load patterns. So our analysis is done, and you can see the analysis, various analysis results now. Maybe let me show you. Maybe the deflection due to dead load. You can see the deflection due to dead load. Where is the highest deflection? You can see that in the terrace floor. Maybe the displacement due to the lateral load. See, displacement due to the lateral, and you can get the displacement value at every single finite element point. Now what is finite element? Let me explain you. Okay, so the best method and the precise method for analysis is the finite element analysis. Finite element analysis. Now what it does actually, let us consider this is an element. In finite element analysis, the software or in the manual process also will be dividing the whole element in finite number of elements. Okay, finite number of elements. Now we'll be getting the moment or the force value for every single element here. So you can understand how precise the values would be, and these values will be, maybe it is a slab, if you consider it is a slab, and these values for every single element, it will be transferring to the beam corresponding to this slab. So the values will be very precise. So this is the best process of analysis, which is a finite element analysis. And if you are going to do a finite element analysis for G+4 or G+5 structure manually, it would take a month or two for you to complete, and it may not be precise and it may not be correct also. But that's why we rely on the softwares. Right? So I showed you how to get the analysis results in just a click and in few seconds. So that's why we need to learn the softwares to work in the industry, right? So response spectrum analysis, time history, we all know it is all about the dynamic analysis of structure. We will be getting the response of the structure, and we'll be taking those values while doing the design. We have time history, modal analysis, and after analysis we have post analysis checks. what we have post analysis checks. Now in after post analysis, we need to do the checks like deflection check, whether the structure deflecting more than the allowable limit. We need to consider the displacement check. We need to get the story drift ratio value. Story drift ratio. Then we'll be getting, so in case of dynamic analysis, we need to see the base shear also, whether the base shear is less than the static load case or not for dynamic analysis, and we need to scale it up if it is less. Scaling of base shear, the concept of scaling of base shear. Okay. Now, while assigning the lateral loads, there is a concept called diaphragm. Okay. So without assigning the diaphragm, this you will not get the values of lateral loads. Okay. Diaphragm is very important to get the precise value or get the proper value of lateral loads. Now, what is diaphragm? How to define the diaphragm? And what is the working procedure of diaphragm? Why you should give it? Will be I have explained elaborately in my course. So then, we have this post analysis checks. Okay, base shear check, story drift, displacement, deflection, and we may get the energy model also. Okay, energy model we can get. After that, after checking all this, we'll be checking the modal checks. Okay, modal checks, where we have mass participation. We need to check the frequency of the modes, frequency of the every single mode cases, right? So all these checks we need to do as per our IS codes, maybe IS 1893, IS 456, okay, IS 456, then IS 870, IS 875. Okay, regarding all considering all these codes, we need to do the stability checks of the structure, and after if the structure is passing all these checks, then only we can go for the design process. Now in the design process, what we have, if it is a concrete structure, then we may have the concrete beam, we may have a column, then walls and slabs. This is about superstructure. Now in case of substructure, we have footings or foundations. So in that we have isolated footings, we have combined footings, we have raft, then we have pile caps and piles. Okay, so while talking about the superstructure, I can show you while designing the beam. Let's just show you. If I click on design ring concrete structure, you can see software is doing it in just few seconds. That's the beauty of the structural engineering software. Now you can see whether all members are passed or not. You can see it is showing all concrete frame members pass the design check. So that's how you can finalize your structure. And so there are so many topics. Let me explain in deep. In between that, we have stiffness modification. Okay, we have finite element meshing. Then we have diaphragm. I already told you, diaphragm. Okay, we have diaphragm. Then we may get P delta checks. Okay, P delta check. It may be considering international codes. Okay, so all these things we need to consider. We need to go for the analysis, and we will do iterations, number of iterations. If it is not passing the checks, then we need to consider higher values of the sizes, or maybe we need to change the orientation. Maybe we need to change the structure orientation, or some shapes we need to change in the structure. So all this, after considering all these things, we need to go for the design. And if there is any issue in the design, then we need to consider increase the values of the sizes of the beams, columns, or maybe you need to give releases. Yeah, one more topic we have, that is moment release. Okay, we have releases, where we should use releases. Okay, moment release, torsion release, and all these topics we'll be covering. I have covered in my online course, which is Superstructure Analysis and Design using ETABS 2016. So that's how you can get a model passed, and then you can go for the detailing of the structure, and you can give the drawing for the construction to be done, or to the municipality to check. So all this process, if you want to do it manually, it may take a couple of weeks or couple of months for you to take, but we may not have that much time to complete, so we'll be relying on the software. So, and if you don't know the softwares properly, then you may get the wrong values and your structure may fail. So that's why the Dreamscape Design and Constructions have taken an initiative. We have started an offline project-based course, where we have in few while I'll be showing in our website. We have different various courses which is project-based, and you'll be solving your projects by your own. By our house, we'll be giving you the classes, and then we'll be doing those projects in front of us. So by this kind of activities, you can learn the proper way of structural design, right? The proper way of structural design. So let me show you our website. So if you go to our website, and if you go to the corporate training section, you can get that we have the structural engineering courses, we have architectural planning and design courses, we have online courses, and we have theory classes also. So today's topic is all about the structural engineering courses, and if you go to the structural engineering courses, you can see we have various courses. Advanced study in structural engineering, where we'll be combining the superstructure analysis and substructure analysis, both using various industry level softwares like ETABS, SAFE, StatPro, Stat Foundation, like that. We have superstructure analysis and design using ETABS 2016, substructure analysis and design using SAFE 2016, and structural analysis and design using StatPro. In that, we'll be using the Stat Foundation also. So you can check our website to get more information about these courses. You can check the fees. You can check our gallery. So our students and professionals have done these projects during the course period. You can see raft. We have isolated footings here, steel structure, and this is our whiteboard. So then so this is our offline classes. But now at this situation, we have started the online classes also. Like while staying at home, you can learn those topics even at your place, and you can get the certification. So if you go to the online classes, just go to corporate training, and you can go to the online classes. You can see we have an online class called Superstructure Analysis and Design using ETABS 2016. So all the topics I have explained today, I have told like we'll be considering for a structural design. All these topics I have covered in this online course. Okay, so after completion of this online course, you will be getting an authorized certificate from our company, and a project completion letter. So what is the project completion letter? You will be completing the project which we are going to do during the course period. Same project you will be doing by yourself, and you will be submitting that project, the files to us, and we will be checking whether your projects are okay or not, and we will be giving you the feedback, and after that we will be getting the project completion letter from our company. So the course fee of this project, this course is 7,000 rupees, and it is for 20 days. You'll be getting the access of this course for 20 days. But now this is the time of today's announcement. We have decided to give this course for totally free. We have decided to give this course for totally free, but there is a condition. We have started an online quiz on reinforced concrete design. So you can attend the quiz, and the best three, means the three highest scorers of this quiz, will be getting this Superstructure Analysis and Design using ETABS 2016 online course for 20 days for totally free of cost. And after completion of this course, the three of them will be getting the certificates and the project completion letter. Now let me show you how to attend the quiz. You just visit our website. I'll be putting this link of our website in the description below. So just go to our website, and at the second, if you go down, you'll be getting this attend quiz option. If you click on the attend quiz, you'll be getting this registration form. Just fill the registration form, all the required things here. Just fill your names, your parents, your guardian's name, but make sure that your name and your guardian's name is proper. You have written in block letter, because these names, if you are in the best three, then your names will be coming in these names will be coming in the certificate. So if it is wrong, you'll be getting the certificate with wrong name, right? So make sure you are giving all this information properly. And after completing this information, if you click on next, you'll be redirecting to the quiz page, and you can attend the quiz. Now you will be having a whole week. We already launched this quiz today, and the last day of submission of your quiz is the Tuesday next week. So we have a whole week to complete this, solve the questions and to submit the quiz. And after completion of your quiz on by Thursday, we'll be publishing the results of each and every one. So you'll be getting the results in our website, in our YouTube channel, in our Facebook page, and in our Instagram page as well. So the highest three scorers will be getting the Superstructure Analysis and Design using ETABS 2016 online course for 20 days for totally free. And along with that, we have another theory course which is Reinforced Concrete Design. So that course also, the three of them will be getting for totally free of cost. So now what if there are number of students who have got the highest scores, like same scores, then we have no option. We need to go for lucky draw. If there are number of students, maybe 10 or 20 students who have got the three same scores, and all of them are highest scorers, then we need to go for lucky draw, and the lucky 3 people will be getting the free course for next 20 days. Then now our next batch is starting from the first week of May. We'll be reporting all of you regarding that. So just I hope all of you get the thing, and you will be attending the quiz. It is already online. You can go through our website, and you can start attending the quiz. And best of luck to all of you. I hope this quiz, you may learn so many things from this quiz, and if you are lucky, or if you get the highest score, you may get the chance to do the course, Advance ETABS course, for free, and you can get certified also. So thank you all. That's all. This video is all about this announcement only, and the quiz is online. You can start attending the quiz.